Hi folks, we're going to take a look at this question here that involves the intersection of lines. So they give us the equation of two lines and they tell us that they intersect at a point, but we notice that in the second line the y component of the direction vector is variable, is given as k, and they want us to determine the value of this k and then the coordinates of the point of intersection. So first thing, they tell us that they intersect at a point. That means that there is a point which is going to satisfy both of these equations. In other words, the x component of this point will be equal in both of the lines, as well as the y component and the z component. So this is what we use to set up a system of equations that we can then use to find the intersection between the lines. So we're going to proceed that way. So we know that we need an x component from the first equation that has to be equal to an x component from the second equation. So from there, we create the equation -3 plus 1s. So -3 plus s has to be equal to 1 plus -3t. So 1 minus 3t. And then from there we continue. We know the y components also have to be the same. So in other words, 8 plus -1 times s. So 8 minus s has to be equal to 4 plus, in this case here, kt. And the z components have to be equal. So 1 plus s has to be equal to 2 plus 8t. And the way in which we solve for the point of intersection, given that we have only two unknowns, the s and the t, is we take two of these equations and solve it as a system of two equations and two unknowns. Now, usually we have the choice as to which equations we would take, but here, since equation 2 has a variable, an extra variable in it, I'm just going to choose not to use equation 2. So I'm going to work with equations 1 and 3 to solve for s and t. So here I notice that there's an s and an s in both equations 1 and 3. So if I subtract 1 by 3, I can eliminate the s variable. So here let's do that. -3 minus 1 is -4. S minus s is equal to 0. So I've eliminated that variable. Here 1 minus 2 is equal to -1. And then -3 minus 8t is equal to -11t. And so now I can solve for t. So I'll bring the -11t to the other side, bring the -4 to that side, so -1 plus 4 is equal to 3, and so t is equal to 3 over 11. Then from there, I can now calculate the s value, so I'll take equation 1 to do that. So from equation 1, we've got I'll just bring the -3 to the other side, so s is equal to 1 plus 3 is 4, minus 3 times t, which I now know is 3 over 11. And I'll turn this into 44 over 11, so I can solve it easily. So 3 times 3, 9 over 11, and 44 minus 9 is equal to 35, so s is equal to 35 over 11. So in order to make the x and z components equal, s has to be equal to 35 over 11, and t has to be equal to 3 over 11. So since we need all three components to be the same, I need equation 2 to also be valid. So I'm going to plug in t equals 3 over 11, s equals 35 over 11, and then from there I can determine what k has to be. So I'll work with equation 2. And here we have 8 minus s, which is 35 over 11, equals 4 plus k times t, which is 3 over 11. And to make things simple, I'm just going to multiply both sides of the equation by 11 so that I can get rid of these fractions. So multiply the left by 11, I get 88 minus 35 equals 44 plus 3 times k, since the 11s will cancel out. And so here I can calculate 3k. So 88 minus 35, so that's 53 minus 44. And here 53 minus 44 is just 9, and then divided by 3 is 3. So there we go. We've solved part 1. So one little comment I want to make, that as you're solving these systems of equations, label the equations and tell me what you're using as I go along. So it makes makes your solution clearer, and if there are any mistakes, it makes it easier for me to find, see if it's a silly mistake or something more serious. Okay, so we've solved the first part of this problem here. We've found what k must be equal to. So now if we want to find the points of the point of intersection, well, we've already found the s and t needed to give us the point of intersection. So I can either replace s into the first equation to find the point of intersection, or take the t and put it into equation 2. Okay, so I'll plug in s into equation into line 1 to find the point of intersection. Okay, so the x component here is given by negative 3 plus s, so negative 3 plus, and then s was 35 over 11. So here, negative 33 over 11 plus 35 over 11 is equal to 2 over 11. Okay, then our y value is given by, if we look up here, 8 minus s, so 8 minus 35 over 11, so that's equal to 88 over 11 minus 35 over 11. So 88 minus 35 is 53 over 11. Okay, and then lastly, the z component is given by 1 plus s, so 1 plus 35 over 11, so 11 over 11 plus 35 over 11 is equal to 46 over 11. And so my answer for part B, the point of intersection, is just equal to 2 over 11, 53 over 11, and 46 over 11. And we are done.